Introduction to CMOS VLSI design. Outline of the subject is Introduction to VLSI. First one is MOS transistor, CMOS logic gate, fabrication process, and overview of the fabrication process. Integrated circuit is we know that it is a transistor on the one single chip, and VLSI stands for the very large scale integrated circuit. Here we use the CMOS, that is complementary metal oxide semiconductor, which we know that it is a fast, cheap and low power transistor. We know that the basic part of it is PN junction. PN junction in that the current flows from the one direction, and here the two terminals are anode and cathode for the same P type and N type. First one is we'll see the NMOS transistor. For NMOS transistor, there are total three terminals: gate, source, drain and body. Here NMOS transistor is look like a capacitor, that is gate oxide and body. Oxide is middle part and the two plates are gate and body. SiO2 is used, is very good insulator, and it is used for this use as semiconductor. Next one is operation of the NMOS transistor. Here for NMOS, body is commonly tied to ground, that is 0 volt. When the gate is at low voltage, P-type body is at low voltage, and source, drain and drain body diode are off. That means no current flows from the channel, that is transistor is in off state. Now for the on stage of the transistor, we have to change the setting, that is when the gate is at high voltage, positive charge is applied on the gate of the MOS capacitor, negative charge attract. And due to this, the negative charge will attracted towards the body, and the inverse the channel undergoes the N type, that is the depletion layer is formed below the channel. That means no current can flow through the N type silicon from the source to channel to drain, and means transistor is in on state. Next, seeing the PMOS transistor. The working of the PMOS or the construction of the PMOS is opposite to that of NMOS. That body is at high voltage, that is VDD, where in NMOS it is at 0 volt. Gate, when the gate voltage is low, transistor is in on stage, and when the gate is at high, transistor is at off stage. Next is we can use the transistor as a switch, that is NMOS switch and PMOS switch. The working of this is exactly opposite. When the gate is equals to 0, NMOS is off stage, is off switch. Opposite to that, PMOS is on switch, and when the gate is 1, NMOS is on and PMOS is off. First one is, by using this PMOS and NMOS, can build the CMOS inverter. That is, it is a combination of PMOS and NMOS connected invertly. The gate terminal of this PMOS and NMOS connected, and the common input is given to the CMOS inverter. Output from the source of the output from the drain of the PMOS and source of the NMOS, and the VDD is applied to the source of PMOS and ground is applied to the drain of NMOS. The truth table for this is, when we apply the input A is equals to 0, that is for the gate terminal of PMOS it gives input 1, and for the N terminal of the gate it gives 1. In this case PMOS get off and NMOS get on. Off means it gives VDD, it gives 0 output, and NMOS is on means it gives 0 output. Means exact opposite output we'll get for the one input. Similarly, for the input 0 we get output 1, that is PMOS is on and NMOS is off. Next one is CMOS fabrication. CMOS transistor are fabricated on the silicon wafer. Now steps involved in the fabrication are lithography, etching, printing. There are different steps for the fabrication. First one is, this is inverter cross section of the NMOS. Here generally we use the substrate as P-type substrate for the NMOS and N-type substrate for the PMOS transistor, and the required well, that is N well for the body of PMOS transistor and P well for the body of NMOS transistor. Next, there are different mask layers are available. Total 6 layers are there. First one is N well, next one is polysilicon, next is N plus diffusion, P plus diffusion, contact and metal. These 6 mask layers are used for the layer structure of the PMOS and NMOS. first step is fabrication. First, start with the blank paper. Build the inverter from the bottom up. First step will be the form the anvil. Cover the wafer. We take the first piece substrate and cover the wafer with the protective layer of SiO2. Remove the layer where the anvil should be built and implant or diffuse the dopant into the exposed wafer strip of SiO2. Next step is oxidation. Oxidation means the P substrate will be oxidized using oxygen or H2. Means growing SiO2 layer on the P substrate at 900 or 1200 degrees centigrade. Next is photoresist. The meaning of photoresist is the means SiO2 layer is exposed to light which is sensitive. We are using the polymer for that, and the softened where they are exposed to the light. Next step is lithography. In this we create a source and drain terminal. Means for that terminal we use the lithography. Is expose your photoresist to the anvil mask. For this we have to prepare a mask for that particular size and expose through the photoresist. Strip of exposes photoresist. Next step is etching. Etch the oxide. We are using here the etching solution, that is hydrofluoric acid. It is very sensitive. Means next only we attack the oxide where the resist has to be exposed. This where we want to make a channel or gate, that portion we use the etching solution only. Next one is anvil. Anvil is formed with the diffusion or the ion implantation. Diffusion is place wafer in the furnace with the air gas. Heat until as atom diffuse into the exposed SiO2 and ion implantation is done. Next is strip oxide. Strip of the remaining oxide using HF. Means we want here the source and we have to create a source and drain terminal. So we strip out the remaining oxide using the hydrofluoric acid. Back to the wafer with the anvil. Subsequent steps involve the similar series of the steps for the source and as well as drain gate. Next one is polysilicon. Deposit with the thin layer of gate oxide. Chemical vapor deposition, that is CVD of the silicon layer. We place the vapor in the furnace with the science gas SiH4. Form many crystals called the polysilicon. Next one is patterning. We are using same lithography process to pattern the polysilicon because we want anvil as well as PVL, two anvil for the two terminals on the P substrate. So we are using patterning here. Next one is N diffusion. Use of oxide and masking to expose the where N plus dopant should be diffused or implant. The N diffusion forms the NMOS and P diffusion forms the PMOS, which is drain and anvil contact. Here P substrate, on the P substrate there is anvil and two contacts are there for the source and for drain. Next one is N diffusion. Pattern the oxide and form the N plus region. Here N plus diffusion mask of that type is used to pattern the source, drain and gate terminals. Next is in the figure we see that we have taken the P substrate, then on that P substrate there is anvil, and after anvil we diffuse N plus dopant on the substrate for the connection purpose. Next is strip of oxide to complete the pattern steps, that is source and drain terminal. First source is on the N plus dopant and second is anvil and N plus dopant on the P substrate. Next one, same procedure for the P diffusion. The set of P plus diffusion, before we use the N plus diffusion, now we have to use the P plus diffusion for the P diffusion. For the PMOS, source and drain substrate contact, same we make the mask and we mask on the P substrate for the connection purpose. Next is finally we have to create the contact for the source, drain and gate terminal. For that we make the mask of the contact where we want it on the P substrate. Now for this for the wiring purpose we use this to cover the strip with the thick field oxide. each oxide where the contact cuts are needed. And finally it goes through the metallization where we use aluminum over the wafer. Okay, this is summary of the introduction, that is what is fabrication and what is MOS transistor, it is gate source drain, and how we use the fabrication.